mass in such a way that here we will get a gaseous compositions proportion differently and liquid composition. So initially we have a, this one G0 and L0. Okay, uh, with this line, but at here what we have a oil and gas. So it will transfer it lighter component at a, in a proportional. So it will reach to G1 composition and liquid compositions are L1. So it's transferring its mass. Okay, in this case. After that, again this process will repeat until we will reach to this tangent line. Okay, so again in next stage this will be G2 and this will be L2. And in next stage, what will happen? It will come into this zone where it will get a miscibility. Okay, and there is nothing too much to think in this case, but just you have to know. Let's suppose uh, my crude oil is toward the left side of that tangent line from that plate point. Then there are chances when I'm injecting the methane. There are chances. Let's suppose if this is point A, where my entire this becomes miscible. Okay, if once it will reach to, okay, sorry, this is my A point, not that one. So once it will reach to that, that means my entire solution will be miscible only. Sorry guys, today you might face many issues regarding to these knots, but from next day I will make sure I will comfortable with this. So let's suppose with this line, this OA line, it will be complete miscible. So at initially it will inside the two phase zone, then it will adjust its mass. So oil will adjust its mass to to become a comfortable with a methane in such a way that it we will have a miscibility condition. Okay, here the one thing which we are observing is that oil start to like change its mass composition. In another way, let's suppose so whenever my point inside this zone, what I will achieve vaporization drive. Okay, because in this zone there are chances. Let's suppose C1 is here, then again it will contact with O inside two phase zone and it will shift toward this A point. But let's suppose if my point is here, then does it belong to that condition, vaporization drive? No. Why? Because we have already seen this condition in LPG gas drive. Okay. My point is below this A, anywhere here, it will directly create a first contact miscible and it will directly miscible with the oil. So this is the key major difference. My oil must be towards that right side of that line and my point should be above that A point. And what is A point? This can be a maximum tangent line you can consider from P, from my oil. Okay, this A point is nothing but maximum tangent line from my plate point and my oil point. Okay, from this. And what is this line? This is the tangent line. Uh, this is the line from my oil and plate point, and this is the line which is the tangent from P. Because at a particular point you will have only a single tangent. You will never get a two tangent at a particular. But okay, because this is that thing, na. In circle, tangents are unique, correct? So this OP line is the line passing from O and P, but it is a line which should be a tangent in previous case. Here, OP is the line which is passing from O as well as from P, but it should be a tangent to that curve. Okay. Are you getting this or?
Yes, sir.
Okay, that is nothing too much thing. Once you will solve the problem which I gave to you will have a more idea. because you can understand na, like let's suppose initially you may have an oil, this oil belong to this, what does it mean? It have a single phase zone itself while it's only oil. But when you are injecting this C1, how it's changed, it started to like its gas composition is G1 and its liquid composition in L1, so it may have a composition it consists the liquid plus gaseous composition as well. And after that it again shift with this methane in such a way it will be miscible with that C1. So now we are injected C1 in such a way that the density of this crude oil definitely will reduce, because what we are doing, we are injecting the that lighter composition. So ये oil यहाँ पे है, मीन्स ये इंटरमीडिएट रीच आप बोल सकते हो थोड़ा, जिसमें C1 थोड़ा कम है, C7 प्लस थोड़ा कम है, तो वो इसके लिए सुटेबल माना जाएगा. ठीक है. नेक्स्ट ड्राइव, just case is just opposite to this in terms of this red tangent line. Okay, what will happen during the next drive? So the next one is the condensate drive. Let's suppose this is C1, again wrong, this is C1, this is C2 C4 and this is C7 plus, and let's suppose my curve is it can be in any shape. It should not be like I'm drawing, because you my drawing is not that much good, so you can understand things, but it can anyway, it can be a perfect circle shape, it may be oval shape, it may be a like not, we can't say, it depends on totally composition. Let's suppose if this is my tangent line. In this case, let's suppose if my oil is toward left side of this line, so let's suppose this is my oil. Okay, and my solvent which I am injecting. So in condensate gas drive, what we can inject? Intermediate component or enriched gas. Okay, what we are going to inject? We can inject the intermediate component or enriched gas. So enriched gas is nothing but it's a C2C6 combination where proportionality of that compositions are higher. Okay, so what we are going to inject? Enrich the gas. So this term you should remember. So in this gas, let's suppose this is my oil. So let's suppose if this is oil, then where can I achieve the let's suppose if this is oil and I should not draw this. Okay, let's suppose keep it as it is. And let's suppose if my gas is not here. In last gas it's a C1, but in this time I'm using from this. So what will be the case? Let's suppose this is my O point and this is my oil point. I'm just shifting because I have drawn that two curve zone, two phase region very small here compared to triangle. So let's say this is the initial case. नहीं हुआ. So this is the initial case. Let's suppose. So let's suppose if this is my initial case. So this is my enriched gas at initial. This A is enriched gas I'm injecting. Okay. So let's suppose what's happened here. So in this case, my in this case, what will happen? Whatever the composition which I'm injecting inside, they will start to shift and it will try to match towards what can I say, towards that enriched component. Okay. Wait, I'm getting call from home. Just wait 2 minutes. Huh? Okay, guys, we can continue. So let's suppose if what will happen here. So this process is entirely reverse of that. So let's suppose whatever I'm injecting, this enriched component will start to condensate. Okay. In above case, what we are observed here, the lighter component from oil start to vaporize, and it will going toward the miscibility. In this case, whatever we are injecting from that, uh, from this enriched gas, it will start to condensate. So this line should be start from this. So this is my L1, this is my L2. Okay, and simultaneously you must have a that tie line for this, so you will get gas composition. Okay, this is gas composition corresponding to this L1, this is gas composition corresponding to this L2, and at the end what it will do, it will change the oil composition and it will miscible once it will pass this zone. Once it will pass this zone, okay, once this composition will change, okay, at that time it will achieve the miscibility. Okay, so here entirely reverse process is occurring. So now you can say what is the difference between the condensating drive and the vaporizing drive. So in vaporizing drive, crude oil composition which are lighter in nature will shift its mass inside the that similar to the similar composition toward the solvent. And in this case, what's happening? Solvent will transfer its mass in such a way that it will stand towards the मिसिबिलिटी जॉन्स एंड इन फर्स्ट कॉन्टेक्ट मिसिबल जैसे ही दोनों कॉन्टेक्ट में आए क्या हो गया मिसिबिलिटी अचीव हो गई ठीक है सो दिस इज द एंटायर केस हाउ दिस ड्राइव्स आर डिफरेंट फ्रॉम ईच अदर and it's totally depend upon what you are injecting and what you have. Okay, that's two are major criteria. Again, temperature, pressure, change this what can I say, binodal curve, size and shape. So that is again important here, but let's keep that as a constant for understanding. Then two major, what you are injecting and what you have. Based on that, this will work. Okay. So any doubt in these three drives, because it may be asked from diagram, it may be asked from direct what kind of solvent in which drive. It may be asked. It may be asked like at what situation, what kind of drive you can observe. So this kind of question definitely you will get in test series as well as whenever you are going through this subject test or all those things. Okay, so this is all about miscible gas drives. Okay, so any doubts in this?
No, sir.
Okay. So just remember two things, how pressure and temperature change this envelope. Second thing, what is the drive mechanism? Like you can understand in which drive mechanism which is transferring its mass, either solvent or crude oil. Third thing, yeah, like you can combine these two things and you can answer accordingly. Okay, let's suppose if I'm increasing reservoir pressure. Okay, just think you have a previous note also if you are not mug up those all things. So let's suppose if you have a reservoir, if you are increasing pressure, uh, and let's suppose I want to achieve vaporizing drive. So shall I increase the methane or what should I do? Okay, this kind of question, just prepare that diagram and you will answer. Anyhow, you will get this kind of question in test series. So definitely you will practice all those things. Uh, okay, so let's talk about miscibility pressure. So anyone know how can we measure miscibility pressure? Miscible pressure or miscibility pressure or miscible pressure, it's proper term. Okay. Which test we use for miscible pressure?
No, sir, no idea.
Okay, no idea. Okay, so we can like this facility definitely you will not get in PDPU. You don't expect that from PDPU. So there is one instrument available in ISM laboratory. Like ISM laboratory is just 10 times what you have in PDPU. Uh, if you will get a chance to go there for your project work, then you can approach your faculty member. They will definitely allow you to go to for your final year project at ISM. So in that case, there is one instrument you can understand is the slim tube test. Okay, this is the instrument which we use. I'm not going to describe this instrument. This is very costly instrument, and like whatever whoever is working on this domain, he can access this. Even MTech student can access this, I believe. So this is the test name you should remember. So what we do in this case, so there is one core fitted inside the um, instrument in which we pass the any solvent and we will observe what percentage of recovery we are getting. Okay, that's the simple mechanism. And once we prepare the graph versus pressure, recovery versus pressure graph. Let's suppose if this is my recovery and at what pressure I'm observing what recovery. Okay, so let's suppose it will start to produce graph something like these points. Okay. And once I will get maximum recovery, this graph will plateau. Okay. So at whatever many faculty member are saying it's 90% or it may be 95%, you can consider as the value as a miscible pressure. Okay. At whatever, let's consider 90% because in books it's written as 90% is sufficient threshold for this. So whatever recovery we observing at a pressure which is equal to 90%, at that pressure we call it as a miscible pressure. So this is slim tube test. I'm not going to discuss the procedure and all those things. So let's remember one thing: LPG's miscible pressure is lowest. Okay, and let's suppose miscible process pressure is lowest and it's useful for a shallow depth. Second thing, uh, methane or hydrocarbon, okay, light hydrocarbon is highest miscible pressure. Okay, and this is used for at a higher depth. Third one, let's talk about CO2 injection. We haven't discussed that yet, but let I'm writing. The benefits of CO2 injection as a miscible injection of gas. It has the lower miscible pressure. Okay, so it can achieve the miscibility easily. But let's just write here those two only. Keep it as separate topic itself. CO2 injection we will discuss later on. So these 2 points just you can note it down and just try to figure it out or just try to quantify this value by your side. Okay. No need to remember value, but just you have idea at what range this pressure belong at what range miscible pressure belong to, and consider common like average reservoir temperature, or you can say consider around don't go beyond 400K. Okay, Kelvin. So this is all about miscible flooding and that process. Any doubts in this, or just try to read it out from that Latin book. Uh, your concept will more clear once you will go through that, and let me know anything I missed or anything I like you would like to know or any doubts you have. Okay, or any doubt for now, then you can tell me because I don't think this is the hard one. Hard one is yet to come, but that we will cover at end. But Whatever theory we are discussing, it's just a logic and it's simple to understand and easy to remember. So any doubts?
No, sir.
Okay. So before moving to the next method, let's discuss about CO2 injection and N2 injection in short form, because now it's not that much hard for us to, like, you can connect this all solvent how they behaves once we inject inside the reservoir with this diagram. Are you able to connect those method, like how this solvent behave with this oil and with how does it force this oil to produce?
Yes, sir.
Good. So let's start discussion. Let's have a brief discussion on CO2 versus N2 studying. So now CO2 is again a gas. It's behave like whatever we discuss. CO2 is belong to vaporizing drive. So we now understand the process flow. But there are speciality in CO2 injections which we are going to discuss here, and similarly N2 injection. So those two are important gases or important non-hydrocarbon gases for us. So let's discuss quickly. Okay. So the first thing, what is CO2? Let's suppose somebody will ask you, what is CO2? Can anyone answer? You know, जब हम 12th में थे तब you know 2 marks मतलब 4 प्रॉपर्टी लिखनी है. तो you know कॉमन 3 प्रॉपर्टीज कौन सी होती थी?
It can be solid or also it can be gaseous.
Yes, so now we are talking about gas, so it must be a gas. Okay, next one. Okay, let me tell you, it's a colorless, it's a odorless, and it's a non-combustion. Okay.
Okay, sir.
Okay, nobody is going to ask, but these three are property. Let's suppose somebody will ask you, then you can say CO2 is a colorless, odorless, and non-combustion. This can be told for anything. Like you can tell these properties for N2 as well. You can tell this for, but just remember one thing, hazardous बोलने से पहले थोड़ा सोचना, ठीक है, whether it is hazardous or not. Like regarding to sulfur and nitrogen, NO, N2O, this kind of stuff are hazardous for health, but with H2S and all things, but these kind of gases might not hazardous. Like CO2, we release CO2, it's inside atmosphere, so it should not be hazardous. Okay. So why we let's think, so it can be a miscible flooding as well as the injection also. Okay, it can further separate, it can be miscible injection or it can be simple immiscible injection with CO2. So that's totally depend upon condition. But why we can use CO2 flooding in place of water flooding, because we know, considering only immiscible condition, and in that case, so why we should inject CO2 and what is the alternative of using single method with CO2 flooding and water flooding. We have alternative for that also, but before that let's discuss. So remember, one important property of CO2 is water is soluble in CO2. Okay, you should remember this, water is soluble in the CO2. Okay, and once it will soluble with CO2, it can form carbonic acid. Anyone remember formula for carbonic acid?
H2CO3.
Yeah, it can be, but just leave it, not required. But just remember, and once it will form, uh, once it will form carbonic acid, it increase the viscosity of water. Okay, mu W will going to increase. Okay, no need to remember. I just wrote equation to make it short and simple, short and sweet. So just mu W is increased, and we know mobility ratio will improve. Mobility ratio improved means its value is near to 1. Okay, another benefits with this injection is, if you have gone through this drilling part, and in that case if you have gone through that clay swelling part, then I have already explained the impact of pH on that swelling. Okay, so presence of CO2, what we are adding, we are adding the CO2, and let's suppose water is present inside the clay. Okay, water, let's suppose, the present inside of the clay, and if it will forming acidic medium, then definitely pH will reduce. Okay, pH, what will happen? pH reduce. Why pH reduce? Anyone? Very simple answer, it's on your board only.
वो एसिड क्रिएट हो जाएगा ना H2 और CO2 की
हाँ,
वजह से.
यस, और एसिड की पीएच क्या होती है? लो होती है. ओके, दैट्स द सिंपल लॉजिक. तो लेट्स से जब पीएच रिड्यूस होता है हमारा, so उस केसेस में if you don't know for a now, uh, just go through production also once. There I have explained the scale formation as well. So it won't allow to form a scale. Okay, it won't allow to form a scale, or I can say it does not allow precipitation of scale. Okay, okay. I don't know it's S or C. I think it's S only. So precipitation of a scale it won't allow because we have already reduced pH. And why it won't form? Then you can go through production video or scale formation video, or you can read one book on that also, Eleanor Robot or something like that. You can go scale formation chapter, and it's on first page only. You will get this information if you don't know. So this is beneficial. Why it's beneficial? That you can connect with your drilling and you can understand these things, but these two properties are important for now for gate as well as for knowledge purpose only, for knowledge purpose also. So how does CO2 works? Okay, so you can consider two things. So we have already told you, I have already told you two things. So whatever solvent is also contact with water and it's also contact with oil. So whenever we are injecting CO2, in that case, it will increase the viscosity of water and it will reduce the viscosity of oil. How? Because oil will be miscible inside oil. Sorry, CO2 is miscible inside oil, or it may be dissolve inside oil, and it can reduce the viscosity. So these are these. Uh, how the what are, let's suppose if I want to tell functionality of these floodings, and how can I say? The first thing first is soluble in oil. तो इट विल ऑयल विस्कोसिटी क्या होगा? कम होगा. वाटर का विस्कोसिटी क्या होगा? इंक्रीज करेगा. थर्ड थिंग, स्केलिंग कम होगा, स्केल रिड्यूस होगा. फोर्थ थिंग, let's suppose if rock type is carbonate. Okay, and if let's suppose it form the acidic medium, then it will etch this carbonate, and if it will etch, then what will happen? It will increase the K. Okay, and fifth one is it miscible with oil. and it will reduce interference tension. Okay, these are the very common points. Let's suppose if GATE is the writing exam, then you should remember these all things. But now you just remember the logic. You understand the logic, and it's well sufficient. Okay. So let's say I have already told you in which drive it belongs. It belongs to the vaporizing drive. Okay, vaporization drive, and another key thing here is its miscible pressure is lowest. Okay, in case of LPG it was lower. In case of this, its miscible pressure is lowest. लोवेस्ट मतलब सबसे कम, जो भी हमने सॉल्वेंट देखे हैं उन सबसे कम. Another benefits of CO2 flooding is it can be applicable over wide range of carbon. That means C41 to C20 to C41. Okay, this is not case with all other flooding. This is unique property of CO2. Okay, we can prefer because this is compatible with other whatever solvent we discuss in for that wider range of the carbon. So we already know that we can't increase C7 in case of we can't this oil must be outside of the left side of this line. It should not be the right side. Same way here it must be a right side of this line. It should not be left side. But CO2, in case of CO2, this range is wider. It means it's compatible with others in terms of this position also. Okay, it may be like, let's suppose if this position of this line may change with CO2, so in that case it is a comfortable with wider range. Okay, these are the key points regarding to CO2. There is one more process which is with CO2 injection itself, uh, which is known as the wake process. Have you heard regarding this wake process?
No, sir.
Okay. So wake process is nothing. It is just a name as the water.
Yes, sir. Water alternating gas.
Yes, water alternating gas. And this is associated with immiscible injection of CO2. Okay. So what we are doing here, what we have observed in water injection, what we are doing in water injection, we had oil and we are forcing them with water. Okay, let's suppose if this is oil, then with front effect, frontal advance theorem, we are pushing this oil with the water. But let's suppose we are using same viscous water for two cases. अरे यार, okay, not an issue. So let's suppose we are using the same water for these two cases. Same viscosity, but let's suppose here oil is the medium viscous, and let's suppose here oil is the heavy viscous. Okay, these two cases. So in this case, there are chances we will get less recovery than these cases. Okay, so let me use this place also because N2 flooding is not that much big. So in this case again, what we are doing, we are going to reduce viscosity of oil first, and then we will push this oil towards the production well using this water. Okay. So in this process, what we do, we will inject oil and we will inject water alternative to gas. That means, let's suppose if this is my oil, then after this we will inject a gas, then alternatively we will inject water, then again we will inject the gas, then again we will inject the water. Okay. So let's say this is my water. Let's say this is yellow is my gas, and this is my black oil. So what we are doing here, we have a production well and injection well, and what we are doing, we are injecting water and gas alternatively. So what are the benefits we are getting? This gas initially drive this oil. Okay. Uh, After that, it can improve the mobility ratio in such a way that this oil, this whatever this gas we are injecting, it will reduce the viscosity of this oil with partial miscibility, and uh, you can say uh, this gas can miscible with oil, but you know this water can be this water and CO2 is again insidely miscible. Like water can soluble inside the gas. That means it's again increase that. But while we are injecting this alternative manner, they have observed the more recovery than continuous injection of one-time gas, and after that continuous injection of gas, the driving water. Okay, in above case, in this normal case, what we were doing, we are initially injecting the solvent, and after that we are driving that by water in a single cycle. But here we are following the multiple cycle, and we are injecting one by one gas and that. So here we know which kind of process is it is. It is a drainage process. We already discussed regarding to that. So CO2 can swell oil. That means it will reduce the viscosity, or you can say reduce the density, and it can increase the. Uh, let's suppose if my density or volume I'm increasing for oil, then it will increase the saturation of oil also, because saturation again related to volume itself, and we are changing volume of oil here itself by injecting CO2 inside that oil. So we are improving the relative permeability of oil also. Okay. So this is the another process. This is good for information, and you should remember what are the benefits here, and how why we are using this. Okay, so in step by step manner, let's suppose in this case your efficiency will increase, and it's let's suppose it can cover more area compared to previous method also. So here we are not. Let's suppose if we are there are chances to occur a miscible rupture, then we are overtaking that issue in this case. Okay. So this is all about CO2 flooding. I think this is well sufficient for examination as well as for understanding. Um, so any doubts in CO2 flooding?
No, sir.
Okay. So quickly, let's compare CO2 flooding with N2 flooding. So what are the benefits of N2 flooding over CO2 flooding and CO2 flooding over N2 flooding? So one benefits we have already observed with CO2 flooding is that it has the lowest miscibility pressure. So we can use it for a shallow depth compared to N2 flooding. Okay, because miscible pressure is higher compared to N2. So definitely this is the major drawback. Another drawback of N2 flooding. Let's discuss that disadvantages first. So if let's suppose miscible pressure is higher, then we require higher depth. That is the relatable. Okay, that are the correlated to each other. The next thing is the let's suppose if my crude oil is viscous. So in this case, N2 is not soluble in water is not soluble in N2. So we are not getting benefits of that increased viscosity with that. Uh, then another one is it can be useful for limited range only. Okay, let me write that also. So first, let's suppose disadvantages over CO2. So first is a uh, higher miscibility pressure. So it require higher depth. second drawback is here, not useful for viscous oil and oil range. So it is a comfortable with C1 to C7 range only. Third thing, mm, water is again not soluble into N2. Just check this point on net. As per my knowledge, water is not soluble in N2, but I'm marking this red. I'm writing, check this. This is the case also. And then what are the advantages? Only single advantages with this N2 is uh, you can say N2 is easily available. It is easily available, and main advantages is it's a highly compressible. And let's suppose if it is a highly compressible, then definitely we required uh, what I can say. Let's suppose where we are injecting N2, whatever the cost we are measuring, that that cost we are measure at the surface condition only. Uh, and whenever it's inside, so we can inject the more N2 compared to CO2, that you can say. Okay, we can inject the more N2, so we can maintain pressure uh, highly than the CO2. So this is another advantage. There is nothing to discuss, or there is nothing to compare between these two methods. Let's suppose if CO2 is available, then we always use CO2. But in case of inavailability of CO2, then we can go with N2 because it can work as similar to CO2. But let's suppose if I have to choose between these two methods, then definitely CO2 has the more advantages compared to all other floodings. So we can go with CO2 because again we it's regarding to that carbon capture policy, and we should we if we are again injecting CO2 inside reservoir for this kind of purpose, then it is again beneficial for environmental issues also. So in that case, we can inject CO2. The only we already discussed drawback also. So CO2 is a vaporizing dry, so it cannot be shoot. It cannot be. We cannot achieve miscibility where this oil is the right side of that. Okay, so it's totally depends. Selection is totally depends upon crude oil composition. But let's suppose if we are going to inject us immiscible, we are going to select immiscible gas injection. Then in case water and gas injection is a greater choice than another other methods, and these methods like all over the world, what is like this all gas injection and are maybe less used. Let me check percentages if I will have. I will tell you that also. Mm, So immiscible gas injection has only 6% of share compared to 100%. Okay. I think this data is for India. You can check it on Google. Not an issue. Okay, so this is all about miscible flooding.
Hello,
Any
sir.
doubts in? Yes.
Sir, in case of LPG, we discussed that it has lower miscible pressure.
Yes, compared to that hydrocarbon gas, it has a lower miscible pressure.
And In CO2 also we discussed that it has lowest miscible
Yes, yes.
pressure.
CO2, it's a advantage of CO2. It has the lowest miscible pressure. Yes.
So sir, if we compare CO2 and LPG, then
Mhm.
which one will have? If we compare
Lower.
CO2,
Yes, yes. Lowest means सबसे छोटा. LPG से भी कम.
means CO2 have lowest miscible pressure
Yes,
compared
yes.
to LPG
Lowest.
also.
Yes, yes. Yes, yes, yes. Lowest मतलब सबसे छोटा. Lower मतलब while comparing two only, it may not be lowest.
Okay, sir.
And at least just try to find this pressure value. So at least you quantify this range also. It should not be a absolute value because it's again depend upon temperature also. But at least I don't know what is the range right now. But you can quantify it. So at least you have an idea in mind. So you will never forget that.
Okay, sir.
Okay. So it's 3:15. Okay. So any doubts if you have, then just let me know. Then we will continue little bit more also today after break. So let's take 10 to 15 minutes break and then we will discuss little bit more about it.
Sir, can I stop the recording?
Yes, you can stop for a while.